everyone, welcome to YourPedia. This is Chandrasekhar, Faculty of Electrical and Electronics Engineering at YourPedia. You all know that HPCL announced one very good notification for electrical engineers, electrical and instrumentation engineers. So this session or this video is about practicing very good questions which are relevant for HPCL paper, especially for electrical guys and instrumentation guys, from the subject electrical circuits or networks. See, from the previous papers analysis, the questions asked in HPCL examination are very easy. So you can't find more easier questions than those, that much easy. But the point that has to be remembered, those who are preparing for HPCL is the questions are covering all areas. Suppose if you take a GATE examination primarily concentrates on important areas or I can say difficult areas or logical areas, but HPCL examination is not like that. HPCL examination is covering all corners of the syllabus. Okay, so if you are preparing for HPCL, you have to cover total width of your engineering syllabus. If it is GATE or other exam, you have to cover in depth, but here depth is not there but width is there, so you have to cover the total width. So weekly once we are going to give very good relevant questions for HPCL preparation, especially for electrical engineers. Yeah, I am going to start with this 20 questions series for HPCL preparation. Okay, yeah, fine. Let's come to the first question. Read the first question. Yeah, calculate the time constant for the RC circuit shown here. He given one RC circuit. He is asking us to calculate the time constant. Okay, what is the time constant formula of RC circuit? See, one point before I start here, that is through these concepts I am going to cover all relevant topics. Okay, formulas, which formula to take, which formula not to take, what is a confusion point while taking formulas, all those things, how to remember formula. I am going to take up all these things, right? So observe here carefully. Yeah, solution. The time constant tau is equal to R equivalent into C equivalent for a series RC circuit. The units of time constant are either it is series RC or parallel RC or any combination of RC. The time constant is R into C. Now, what is the time constant of a RL circuit, either series RL or parallel RL, any combination of RL, that is L equivalent by R equivalent. See, this is for RC circuit. This is for RC circuit. If you see, this circuit is having only R and C. Same way, time constant tau is equal to L equivalent by R equivalent. Yes, its units are also seconds. Time constant, time units are seconds only, right? For RL circuit. For RL circuit, right? For RL circuit, right? Now, observe carefully. Let's calculate for the given question. I have resistances and capacitance. When it is required for you to find time constant, you stand at the capacitor. Yes. Remove it. Then you find resistance from here. Means looking into that terminals. Means I can say Thevenin's equivalent resistance we have to find. Thevenin's equivalent resistance. If you are finding Thevenin's equivalent resistance after removing the capacitance, I can say R equivalent is equal to this is 50 short circuit. You know, when you are finding resistance, voltage source has to be short circuited, current source has to be open circuited. Sir, why voltage source has to be short circuited? We are nullifying the effect of sources. Nullifying the effect of source means voltage source effect has to be nullified, means voltage must be equal to 0. Voltage is equal to 0 in a short circuit. In the same way, I have to nullify the effect of current source, means current has to be made into equal to 0. Current is equal to 0 only in open circuit. That's why I am short circuiting it. So R equivalent is what? 120 into 80. 120 is in parallel with the 80 by 200 plus 12. Observe it. 120 in parallel with 80. 120 into 80 by 120 plus 80 is 200 plus 12. So R equivalent is equal to, yes, Yes, this gone. So to force it is 48 plus a 12, it is a 60 ohms. How much it is, ma? 60 ohms. You can check. It has 60 ohms calculation. How much is C given? C equivalent or C is equal to 200 microfarads, then 200 microfarads, then tau is equal to 60 into 200. Micro means 10 to the power of minus 6. So how much it is? 12,000, right? 60 into 200. 6 into 2 is 12 into 10 cube. 12 into 10 cube into 10 to the power of minus 6. So 12 into 10 to the power of minus 3. It is 12 milliseconds. 12 milliseconds. The option is C. Choice is C. Choice C is the perfect answer for the given question. So this way, most of the questions are very simple which are asked in HPCL examination. See, whatever be the combination, for RC circuit the time constant formula is RC, for RL circuit time constant formula is L by R. Okay, yeah. Let's go to the next question. See, sometimes this kind of very simple questions also will be given, like just a definition. Ampere second is the unit of, he is asking what is, whose unit is amperes into second. Now let's write, first one is EMF, power, electric charge, energy. See, I is equal to dq by dt. I is equal to, I is what? Current. The rate at which charge flows is called as current. The rate of flow of charge is called as current. So the units of I is amperes. Amperes is equal to, this is let keep it as charge only, charge, electric charge in fact. I am not writing its units, this is electric charge, electric charge whose units are coulomb. Its units are coulombs, yes, by seconds. Now you are going to get, observe here, electric charge units are, the units of electric charge are what? Yeah, this is amperes seconds. Ampere seconds. The option is electric charge. Yeah, he given ampere second. Choice, this is also C. Choice is C. So easy question. You not check all. Being electrical engineers, we are very familiar with the formula of current, voltage, power and all these things. Okay, power, not only formulas with units also, right? Let's go to the next question. Yeah, this question, a geyser, water heater, geyser means water heater, is operated from 230 volts, 50 cycles per second. C by S is cycles per second. Yeah, I am writing the given data. 230 volts is the RMS value of voltage. Sir, he did not mention this one as RMS value. If he not mentions, by default the given voltage is taken as RMS value. Remember, suppose if it is maximum value or peak value, he will mention very clearly as the peak value of 230 volts. If not mentioned, that one is RMS value. Yes, comma, 50 cycles per second. 50 cycles per second, that is also can be written as 50 hertz. 50 hertz. 50 hertz means 50 cycles per second. Hertz frequency means what? Number of cycles per second, right? Frequency means the frequency of instantaneous power consumed by the geyser is the frequency of power is equal to 2 times of supply frequency. What is the supply frequency? This one very easy to prove. Proof not required for us. If you want, you take a Vm sin omega t into Im sin omega t, you multiply it. And you find it. You are going to get the frequency as double frequency. Power frequency is 2 times of supply frequency, that is, yes, 2 into 50 cycles per second is equal to 100 cycles per second. Choice is, yeah, choice is what? Choice is C. This is also choice C. If some of you want proof for sir how the power frequency is 2 times of supply voltage or current frequency, supply voltage or current frequency, yeah, just with not with the formulas, I'll show you with respect to waveforms, not with formula. Simple proof I'm going to take up. This proof anyhow not required for you, but sir, I want to understand the concepts, background of the concepts. Yeah, this is the voltage you are supplying. This is the voltage you are supplying to a resistance. You know, let me draw. This is the voltage you are supplying to a resistor. Now, what is the formula for current through a resistance? Current through a resistance is equal to voltage divided by resistance. I of t is equal to V of t by R, right? Now, that is voltage. The current also I'll draw. Yes, this is omega t. Current also I am drawing. This is I of t. This is I of t. Yes, or current there only I'll draw with a different color. Okay, this is the current I can say. If I am taking resistance greater than 1, yes, resistance. See, I of t is equal to current is equal to V of t by R. So I of t is equal to, this is Vm sine omega t by R. So I of t is equal to Vm by R into sine of omega t. So this is the maximum value of current. Means the waveform of current and voltage both are exactly same. This is voltage waveform, this is the current waveform, both are same, but only difference is magnitude difference. Now what is power? Let me take up power here. Yeah, what is power? Instantaneous power. Power is equal to current into voltage. Current positive, voltage positive, both are positive. Positive into positive will be positive. This is the instantaneous power. P of t I am drawing. Yes, this is the power. Here current is negative, voltage is also negative. Negative into negative is positive. Yes. Here again both are positive. Both are negative. Yes. Therefore I am going to get it as positive. If you observe, for one full cycle of either voltage or current, this is one full cycle of voltage or current, how many cycles of power we got? 2 cycles. What is a cycle which is repeating is called a cycle. So here itself, suppose if I take this one as 0, this one as pi by 2, this one as 2 pi, yes, this one as 2 pi. So for 2 pi means or 360 degrees, 2 pi radians or 360 degrees, both are same. For 2 pi radians or 360 degrees I am getting one cycle here, but here that cycle we are getting only for, yes, so this is not 2 pi, this is 2 pi only. No, I wrote wrong. This is pi. Sorry. 1/2 cycle in sine is how much, ma? This is pi. This is 2 pi. Yeah. So I am getting one full cycle for 2 pi. 360 degrees means one full cycle. But here for pi radians or for 180 degrees itself I am getting one full cycle. For 2 pi radians or 360 degrees I am getting 2 full cycles. Right. So power frequency is 2 times of voltage or current supply frequency. Right. Yeah. Let's go to the next question. Read it. A purely capacitive circuit. In a purely capacitive circuit, the instantaneous power curve is a sinusoidal of dash the frequency of V and L. In a purely capacitive circuit. Yes, let's try to correct this question. There is some mistake in the question. We'll see. In a purely capacitive circuit, the instantaneous power curve is a sinusoidal of dash frequency of V and I. It is not L, V and I in fact. Yeah, let's see. Purely capacitive circuit. Yeah, this is purely capacitive. It is not having any resistance, right? This is some voltage. AC voltage and we are going to apply. If I apply DC voltage, you know the concept very clearly. Current is not continuous. Only for quarter cycle, first quarter cycle current will flow. Once it fully charges this capacitor, after current flowing will be equal to 0. So this is capacitance, but this capacitance will be represented as minus J XC. So this is the current I and this is the voltage V. Yeah, let's write V is equal to Vm sine of omega t. We all know that current leads the voltage by 90 degree in a purely capacitive circuit. In a purely capacitive circuit, current leads the voltage by 90 degree. Therefore, it will be Im into XC, not XC, into omega c. Im by Vm by XC sine of omega t plus 90 you get. Right? Now he's asking the instantaneous power curve is sinusoidal of dash frequency of V and I. Let us draw. Previously learned concept is going to be useful for us. I am drawing same question, in fact same as the previous question. What is this? Here on this reference, both voltage and currents I am going to take. Both voltage and currents I am going to take. Let me draw the voltage first. This is the voltage. 2 full cycles I am taking. 2 full cycles means 720 degrees. 1 full cycle means 360 degrees. Half cycle 180. Quarter cycle 90 degrees. Right? This is voltage V of t. Now, we all know that in a capacitive circuit, current leads the voltage by 90, purely capacitive. Now, this is, I can say like, just a minute. Let me take the references. This is the voltage. Current also I am taking. Current also I will be taking. Just to draw it carefully, I am doing it. Observe. This is the current. Yeah. Current is cosine because leading. Which one leads? Cos leads sine by 90. Right? Now, if I multiply these two, I am going to draw instantaneous power here. I am going to draw instantaneous power here. He is asking about the frequency. In fact, he is asking about the frequency. See, I am dividing into this way. First quarter cycle is this one. First quarter cycle. Second quarter cycle. Third quarter cycle. Fourth quarter cycle. Yes. Fourth quarter cycle means 1 full cycle. Fourth quarter cycle means 1 full cycle, right? Yeah, observe it. I am plotting it. Observe it, I am plotting it. Okay. Here, in first quarter cycle, if you observe carefully, positive, na? Current positive, voltage positive, current is also positive. In first quarter cycle, it is positive, right? Second quarter cycle, voltage is positive, but current is negative. Therefore, it is negative. In third quarter cycle, yes, this is the third quarter cycle. In third quarter cycle, voltage is negative, current is also negative. In fourth quarter cycle, yes, this is the fourth quarter cycle. This is 1 full cycle. In fact, this is 2 pi. This is pi. Voltage I am taking it as reference. Yeah, pi 2. See, this is pi by 2. This is pi by 2. Just a minute. This is pi by 2. This is third quarter cycle. It is 3 pi by 2, means 270 degrees. 270 degrees. Up to pi by 2, positive into positive is positive. After pi by 2, positive into negative is negative. From pi to 3 pi by 2, negative into negative is positive. This is, sorry. From pi to 3 pi by 2, pi to 3 pi by 2, voltage is negative, current is also negative. It is positive. From again 3 pi by 2 to, see, this is 0, this is pi by 2, this is pi, this is 3 pi by 2, this is 2 pi. From 3 pi by 2 to 2 pi, current is positive, voltage is negative, therefore it is negative, right? If you see, in 1 full cycle, I got, for 2 equal amount of time, 2 times equal amount of angle, positive and positive, 0 to pi by 2, pi to 3 pi by 2. Yes, and for 2 equal amount of time, it is going to be negative. Yeah, let me draw. Suppose See, I'll draw shape of the waveform is not that important for me. I'll draw sinusoidal only. Okay, positive, negative, positive. Yes, it is negative. Yeah, power is positive, negative, positive, and negative. Observe it carefully. See, for one full cycle, I got 2 full cycles of power. So the frequency of power is double that of voltage and current supply frequency. Come back here, it is double. See here, shape is not that important. Again, for next cycle also the same will be repeated. For next for voltage next you are taking, it will be repeated. Yes or not? Observe it. Positive, negative, positive, negative. If you want, I'll check for next full cycle also. Voltage positive, current positive, here it is positive. After that, next quarter cycle, this is the next quarter cycle. Yes. Voltage positive, current negative, negative. After that, negative, negative. Yes. After that, negative, negative is positive. And after that, yes. See, first quarter cycle, second quarter cycle. This is the third quarter cycle. Yes, up to here. This is the fourth quarter cycle. Yeah. Voltage is negative, current is positive. This is negative. You see. Positive, negative, positive, negative. Yes, the power frequency is double that of voltage or current frequency. See, sometimes it may become difficult to understand the question itself. She is asking sinusoidal of double the frequency of voltage and current. But for yeah, how many number of cycles we got here? Just a minute. How many number of cycles we got here? I got 2 cycles per second. This is one cycle. This is second cycle. But for resistance also, instantaneous power is double that of supply frequency. But there I got see, any repetition, any continuous repetition will be calculated in the terms of frequency. Here 2 cycles. So this first cycle, this is second cycle. 2 cycles for one cycle means number of cycles are doubled. Here also if you see, for one full cycle, 2 cycles. This is one repetition. This is one repetition. So this got repeated here. This got repeated here. Means for one full cycle, I got 2 cycles. Here also power is frequency is doubled. Frequency is doubled. Yes, 100 cycles per second. Yeah. Let's go to the next question. Let's go to the next question. It's asking, use the mesh current method. Calculate the voltage across 8 ohm resistance. See, he need not to say that mesh current method. Some method I am going to take up. I don't take mesh current. As it is an objective examination, what are the maybe the method he mentioned, but in which method I feel comfortable, I am going to take up, right? Yeah, observe here. So he is asking across 8 ohms. He is asking across 8 ohms. Then the simple thing is, let's take this voltage as VA. Let's take this voltage as VA. Yeah, he only given VA. This is the reference I am taking. This is the reference I am taking. Yeah. Now I am writing KCL there. I am writing KCL there. The current, this is VB I take. This voltage I take it as VB. Yes, that voltage I take it as VB. Yeah. Now what is this KCL? KCL at node A. At node A. Yeah, write it. VA by 8. Yeah. This current is leaving. This current is leaving. I take this current is also as leaving. VA minus plus VA minus 40 by 2 plus VA minus VB by 6. VA minus VB by 6 is equal to 0. What KCL says, sum of all the currents at a node is equal to 0. Sum of all the currents entering is equal to sum of all the currents leaving, right? Here I taken all the currents as leaving, no entering currents. So sum of all the currents leaving is equal to 0. You get one equation from this one. You get one equation from this one. Now, in the same way, write KCL at node B. At node B. This is node B. Okay. This is node A. Yeah. What is that? VB minus VA by 6 plus VB by 6 plus VB minus plus VB minus, yes, VB minus 20 by 4 is equal to 0. This is equation 2. solve equations 1 and 2 to get VA and VB. If you solve the equations 1 and 2, you are going to get VA and VB, right? Let's go to the next question. Yeah, this is also simple question, direct question. The power factor is defined as, say, the power factor is equal to P by S, where P is real power, that is P, by S is apparent power, it is S, where S is equal to root of P square plus Q square, where Q is equal to reactive power, and its units are watts. Yeah, some questions may be asked, what are the units of reactive power? Yeah, that kind of questions are also possible in HPCL examination. Okay, the real power units are watts. This is in watts. I write here P we wrote there. P units are watts and S units are volt amperes, VA, volt amperes. What is saying? The power factor is the ratio between true power and apparent power. See, the real power is also called as true power, or what is this is called as true power. This is also called as what? True power, right? Choice B is the perfect answer for the given question. Let's go to the next question. Yeah, the next question is, it's a very good question. A single phase 230 volts 1 kilowatt heater is connected across single phase 230 volts 50 supply through a diode. Yeah, he's saying that there is a resistance of 230 volts, 50 hertz, yes, 1 kilowatt. This is the power rated power drawn by the heater. Then from that, power is equal to V square by R. This V must be always RMS value. That implies 1 kilowatt is equal to V square 230 whole square. Always the given voltage is RMS value unless he mentions it as a peak value. Suppose if that fellow says that this is peak value, then it is peak value, otherwise it is always RMS value. So we get this resistance R is equal to 230 square divided by 1000. This is the resistance you are going to have. But what he said, he is connecting that heater through a diode. Observe this. This is a diode. Now, if diode is connected, how much voltage will appear across this resistance? Only half wave. Let's derive that one. What is the RMS value of half wave? Let's derive. Within no time, I'll complete the derivation. Okay, RMS value of half wave. Yeah, see, this is a half wave rectifier output. That is half wave rectifier. In fact, for only half cycle, your input is present from 0 to pi. From pi to 2 pi, its value is absent. Yes, this is Vm. What is the RMS value of a full wave rectifier? Vm by root 2. Or full wave, sine wave, any sinusoidal wave, full wave, it is Vm by root 2. But it is half wave. Now, what is Vrms? So, Vrms square is equal to 1 by 2 pi integral 0 to pi Vm square sine square omega t d of omega t, right? So Vrms square. Now Vrms square is equal to Vm square by 2 pi. Let's take outside of the integration sine square. What is the integration of sine square? Sine square can be written as 1 minus cos 2 omega t by 2 integral of 0 to pi 1 minus cos of 2 omega t d of omega t by 2. Now Vrms square is equal to Vm square by 4 pi you get. This will be pi minus 0. This will be 0 if you do the integration. One integration is with respect to omega t is omega t upper limit is pi, lower limit is 0, pi minus 0 is pi. Now cos 2 omega t integration is sin 2 omega t by 2, sin 2 omega t, sin 2 pi 0, sin 0 0, therefore that factor entire will become equal to 0. That's why I am not considering. Therefore Vrms is equal to this pi gone, Vrms is equal to Vm by 2. Yeah, for full wave I am writing note point here. Note, yes, for full wave, for full sine wave, Vrms, yes, Vrms is equal to Vm by root 2. For half wave, Vrms is equal to Vm by 2. Right? Now he is asking, what is the question? In the question he is asking us to find the power. He is asking us to find the power. Let's find out. Simple question. Yeah, good question it is. But now power is equal to Vrms square by R. Vrms is Vm by 2 by R is, yeah, previously we got it as 230 square by 1000. How much is Vm? 230 into root 2 by 2 by 230 square by 1000. You simplify, you are going to get the perfect answer. So what is the relationship between maximum voltage and RMS value of sinusoidal waveform? For sinusoidal waveform, Vrms is equal to Vm by root 2 for full wave. Yes, Vm is equal to Vrms into root 2. That fellow given Vrms as 230, from that I found a Vm. But what is the halfway rectifier output RMS value? Vm by 2. Yeah, it is not by root 2. Vm by 2 it is, yes, Vm by 2 by resistance value is 230 square by 1000. Solve it, you are going to get the answer. Yes, you can get the answer, right? Yeah. Next question. Yeah, what he is saying? A series RLC circuit with a series resistance of 50 ohms. Yeah, he is saying that resistance is equal to how much 50 ohms, and inductance of 0.01 Henry, and capacitance C is equal to 100 microfarads, is applied with an AC voltage of 200 volts. Quality factor of the circuit at resonance is, in fact, quality factor we have to find at the resonant condition only. Q is equal to omega naught L by R is the formula, general formula. I am asking you to remember, where omega naught is equal to resonant frequency, that is equal to 1 by root LC, not 2 pi, F is 1 by 2 pi root LC, under root of LC. Now Q is equal to 1 by under root of LC omega naught into L by R. Therefore Q is equal to 1 by R into under root of L by C. Under root of L by C. You have the value of R, you have the value of L, you have the value of C. Substitute all those values, you are going to get the answer. Let's go to the next question. Yeah, this question is direct formula. He given two coils connected in series with a series aiding. Sir, how do you know that those are series aiding? See, dot is here. After that, dot is here. Means dot is placed at the starting of both the coils. Or if it is kept at the ending of both the coils, then that is aiding, right? But for one coil it is at the starting, another coil it is at the ending, then it is opposing. For series aiding, solution, for series aiding, L equivalent is equal to L1 plus L2 plus 2m. For series opposition L equivalent is equal to L1 plus L2 minus of 2m. Clear? That one you have to remember, right? Let's go to the next question. The option here is option A, choice A, direct answer, choice A. Let's go to the next question. For the network shown in the given figure, find the Thevenin's equivalent resistance as seen through the terminals A and B. So these are the terminals A and B. Thevenin's equivalent means you have to open circuit the current source and short circuit the voltage source. Now this is 5 ohms. This is 5 ohms in parallel with 10 ohm. That is in series with 10 ohm, right? And this is 20 ohms. These are the terminals A. This is the terminal B, right? At A and B, yes, 20 is there. 5 in parallel with 10. This combination will be single resistance in series with 10 in parallel with 20. This is my A, this is my B. This is A, this is B. How much this will be? 10 into 5 by 15. 50 by 15. Yeah, how much it is? 50 divided by 15. 5 3s, 5 tenths. This is 10 by 3. 10 by 3 plus 10. How much is 10 by 3 plus 10? This is 10 by 3. This is 10 by 3 ohm. This is 10 ohm. This total will be 40 by 3. 40 by 3 in parallel with 20. So RAB is equal to 40 by 3 in parallel with 20. So 40 by 3 into 20 by 40 by 3 plus 20, right? So RAB is equal to 40 by 3 into 20. This is 100 by 3. So 40 into 20 by, yes, 40 into 20 by, yes, 100 it is, because by 3 will get cancelled. Now how much it is? 40 into 20, 0 0 gone, this 0 0 gone, yes, it is 8 ohms. 40 into 20 is 800 by 100, it is 8 ohms. That is not there in the options. Check the calculation, check the calculation carefully. I think we did correct only. This is short circuit, these are in parallel, that is in series. 5 in parallel with 10, it is 50 divided by 15 in series with 10. So 10 by 3, yes, 50, 10 into 5, 50 by 10 plus 5 is 15. So 5 3s, 5 tenths, yeah, 10 by 3 only. 10 by 3 plus 10, it is 40 by 3. 40 by 3 in parallel with 20. 40 by 3 into 20 by 40 by 3 plus 20. So if you do that, you are going to get it as 800 by 100. Yes, it is 8 ohms. Options are not matching. Okay, let's go to the next question. The network shown in figure, find the current through R3. Where is the resistance R3? This is R3. He is asking that current. Yeah, observe it. Solution. Just take some voltage here as V at that node by applying KCL at node A. I call that one as node A. This is node A I call. So what is that? V by 2 plus V minus 7 by 1 plus V minus 28 by 4 is equal to 0. If you solve this one, how much are you going to get? So V plus V by 4, this is V by 2, right? 0.5 V. 0.5 V plus V minus 7 plus 0.25 V minus 7 is equal to 0. So 1.75 V is equal to 14, right? Is equal to 14. So 1.75 means, yeah, so V is equal to 14 divided by 1.75. So I is equal to, yeah, I is equal to what? V by 2. I is equal to V minus 7 by 1. So how much it is? 14 by 1.75. minus 7 by 1. Solve this, you are going to get the perfect answer. Very easy question. Let's go to the next question. Find the equivalent capacitance of the network shown in the figure given in the given figure. He is asking about equivalent capacitance. See, these two capacitance in series will be C1 in series with C2. If there are two capacitances like this in series, if this is C1, if this is C2, so C equivalent is equal to C1 C2 by C1 plus C2. If there are two capacitances like this in parallel, yes, this is C1, this is C2, simply C equivalent is equal to C1 plus C2. So here these two are in series, 200 picofarads, 200 picofarads are in series, then the resultant will be 100 picofarads. 100 in parallel with 100, yeah, I should not add like that. Here that fellow kept open, I should not add. This is 100, this part is in parallel with this part. This 200 in series with 200 will become 100, 100 in parallel with 100 will be 200, 200 in series with 100, 200, yeah, this is C4 is in series with this total, therefore I can write like that, like this, C equivalent is equal to 200 into 100 by 300, then C equivalent is equal to, yes, 200 by 3 picofarads. 200 by 3 picofarads, choice B, perfect answer. Let's go to the next question. If the current changes from 4 amperes to 6 amperes in 1 second, means di by dt, di is what? I2 minus I1 by T2 minus T1. I2 is 6, I1 is 4. This change of time is 1 second. Induces 40 volts in a coil. Then the inductance is V is equal to L di by dt. This is 40 volts given. L is asking us to find. This is 2. That implies L is equal to, yes, 20 Henry. L is equal to 20 Henry. That's all. Direct question it is. Direct question it is. Let's go to the next question. In the circuit below, the power supplied by the voltage source, underline power supplied. Okay. Generally, source means it has to supply. If it is supplying, positive, but it is absorbing, suppose negative. Load means it has to absorb. If it is absorbing, it is positive. Power is positive. Suppose if load is supplying, it will be negative. Right? Please do remember that. Yeah. How much is this current? This current is 0.5 amperes. This current is 0.5 amperes. So I'll assume a voltage of V here. Let me write KCL. V by 120 plus V minus 60, sorry, V minus 15, V minus 15 by 60. So this current is leaving, this current is also leaving, but this particular current is entering. If you see the arrow mark, sum of the leaving currents is equal to sum of the entering currents, 0.5. So V into, yeah, this also can be written as 2V by 120. So this is by 120, V by 120 I will take common, 1 plus 2 it is. 1 plus 2 is equal to 0.5 plus 15 by 60. 15 by 60 please, not 16. 15 by 60. Right? So V into 3 by 120 is equal to 1 by 2 plus 15 by 60. So 340s it is gone. So V by 40 is equal to, this is 16, this is 8, this is 15, right? Yes or not? This is 8, yeah, 8 by 16 is 1 by 2, 15 by 16. So how much is 15 plus 8? Let me take a new page. Let me take a new page and I'll do there. Yeah. V by 40 is equal to 15 plus 8. Yes, how much it is? 23. 23 by 60. So V is equal to 23 by 16 into 40. This is the voltage of node V, this voltage. Now how much is the current, what is asking, the power supplied by the voltage source. The current flowing in this one is, suppose say if I say it as I is equal to V minus 15 by 60. I is equal to, yeah, V minus 15 by 60. So I is equal to V is 23 into 40 by 16 minus 15 by 60. If you observe carefully, need not to solve. I can say that I is negative. Yeah, sorry, positive. Sorry, I is positive. Why? Because this part is always greater than this part. Yeah, because see, this is 15, right? 15. Downside it is 16. See, this 23 into 40, I can write like this. See, very simply, calculations are very important. How much it is? I can say 16 into 15. Yeah, 15 into 16. How much it is? Yeah, 6 5 30, 9 5 1 0. How much it is? 4. This is 240. This is 240. This particular value means after simplification. Yeah, let me write. After simplification, see this one, I is equal to, yeah, already arrow is there. Yeah, I is equal to 23 into 40 minus 240 by 16 into 60. I can say this part is 23 into 40 is greater than 240, therefore I is positive. What you need, sir? I is positive means current is entering. Really it is entering. If current is drawn, if positive current is entering into the positive plate of a DC source, then it is absorbing power. How much it is? Absorbing. Right? So it is not supplying, in fact it is absorbing. What is the formula for P? P is equal to V into I. P is equal to V into I, that is equal to 15 into this total part you put here, but power supplied is equal to minus P, what you got here, because it is absorbing. He asked about supplying. So the power of the source we calculated, we got as V into I, but whether it is absorbing or supplying, it is absorbing. But he asked about supplying power, therefore it is the negative of absorbed power. Answer should be negative. Yeah, with the negative there are two options. Check this calculation, do this calculation, you are going to get one option among those. Next question. A circuit draws an active power of 1000 watts and reactive power of 1000 watts. Okay, from a 200 volt source, 50 hertz AC source. RMS value of the current drawn from the source is, he is simply asking about the RMS value of current. Here some formulas I am going to give, please look here. AS is equal to VI is equal to root of P square plus Q square. So I is equal to under root of P square plus Q square by V. What is I? Root of P square. How much is P? 1000, right? Under root of, this is 10 cube square, 10 to the power of 6 it is. 10 to the power of 6 plus 10 to the power of 6 by, how much it is? 200. Yeah, 200. So I is equal to 10 to the power of 3 root 2 by 200. So this is going to be cancelled 5 times. I is equal to, yeah, I is equal to 5 root 2 amperes. I is equal to 5 root 2 amperes. Choice is B. Let's go to the next question. A 200 volts 50 hertz inductive circuit takes a current of 20 amperes at a lagging power factor of 0.8. The inductive reactance of the circuit is, very good question, simple question. So V is equal to 200 volts is given. Yes, I is 20 at an angle of minus cos inverse of 0.8. Yes, minus cos inverse of 0.8. Okay, Why? Current lags behind the voltage, that's why it is minus. What is y cos? He given power factor. What is that power factor? Cos phi. But I need angle here. So cos phi is some 0.8, then phi is equal to cos inverse of 0.8. But current lags, that's why I taken this way. Now what is z? Z is equal to V by I, that is equal to 200 at an angle of 0 degrees by 20 at an angle of minus cos inverse of 0.8. This gone. Okay, how many times it is gone? 10 times it is gone. So Z is equal to, 10 times it is gone. 210. 10 at an angle of plus cos inverse of 0.8. Now Z is equal to 10 cos inverse of, 10, that is cos inverse of 0.8. Z is equal to cos of, cos inverse of 0.8 is the resistance, plus J 10 into sine of cos inverse of 0.8 is what? Is reactance. This is X, this is X, this is R. So Z is equal to R is how much? R is 10 plus J 10 sine of cos inverse of 0.8. With this you have to get the angle. Okay. So if you do this, you are going to get it. See, as without calculator getting cos inverse of 0.8 is not possible. So there is a need of calculator, or mod Z. How much is magnitude of Z? Magnitude of Z is 10, right? Magnitude of Z is 10. Now root of cos inverse of 0.8, it is 8 ma, sorry, it is not 10. If it is 10, no, it is not 10. This is not 10, this is 8. So I can write like this, this is 8. Come on. This is not 10. Cos inverse gone ma. 10 into 0.8 is how much? 8, right? This is 8. Now tell me, what is the magnitude of Z? Z magnitude is 10. So mod Z is equal to root of R square plus X square, don't know. That is mod Z is equal to 10 is equal to 8 square plus X square. Yes, mod Z. See, magnitude of Z is Z square, it is 100. X square. From this one, X you are going to get it as 6 ohms. 100 is equal to 8 square plus X square. I'll explain this one once again. Okay. Magnitude of Z I know. How much it is? 10. From this one, 10. Resistance I got. If I have Z and R, I can find X. Why? Because mod Z is equal to root of R square plus X square. Let's go to the next question. The RMS value of, what is the option for the previous question? Option for the previous question is inductive reactance is asking, right? It is 6 ohms. Choice A. Perfectly suits. Next question. RMS value of the current flowing through L1, L2 and C in the shown in the circuit below are 0.5 amperes, 0.3 amperes and 0.2 amperes respectively. Total current drawn from the source is. He is asking about this current. As L1, L2 having both angle, both the currents will be directly added. You know, if this is a voltage reference, I am taking reference means 0 degrees. If I am taking this one as voltage, if I am taking V as a reference, voltage V what he shown, then inductor current lags like this, capacitor current leads like this. This is IC. How much is capacitor current? Capacitor current is 0.2 amperes. 0.2 amperes. But inductor currents, we have two currents. One is 0.5. Suppose if this is 0.5 and if this is 0.3 amperes, the total will be 0.8 amperes. But net current I will be I minus IL. This is IL, entire IL. So I is equal to I minus IL. I is equal to IL minus IC. So I is equal to, I am going to get it as 0.6 amperes to the downside. 0.6 amperes. Simple question. Let's go to the next question. An AC voltage is applied to an RL circuit with a resistance of 50 ohms and reactance of 50 ohms. Okay. So Z is equal to R plus JXL 50 plus J50. When applied with a sinusoidal varying voltage, the current flowing will lag behind the voltage by, he is asking phase angle phi. Phi is equal to tan inverse of 50 by 50, that is equal to 45 degrees. Phi is equal to, simply answer is 45 degrees. Yeah, what is the angle of Z? Because I is equal to V by Z. I is equal to V by Z. So current lags behind the voltage by with an angle of Z, because voltage angle is 0, V at an angle 0 by Z. So with lags of 45 degrees, choice C. Next question. A capacitor C connected to a single phase 50 Hz 240 volts AC supply draws a current of 24 amperes. So I is equal to, in fact IC is equal to 24 amperes. Okay. What would be the current if the voltage applied is not charged, it is changed? If it is changed to 200 volts 50 Hz, fine, I'll do it. Observe. So you know, IC is equal to V by XC, V into this is omega C. So IC is directly proportional to V, and this omega is 2 pi f, V into 2 pi f into C, V into f. Now if I write IC1 by IC2 is equal to V1 F1 by V2 F2. So IC2 is equal to, yeah, IC1 into V2 F2 by V1 F1. So IC2 is equal to IC1, how much it is? 24 into V2 200 into F2, how much is the frequency? 60 by V1 240 into this is 50, right? So if I simplify, IC2 is equal to 0 0 gone, 6 4s, 0 0 gone, 5 4s, this is 4 by 4, this is equal to 1, this is also 24 amps. There is no change in the current. Why? Because that fellow decreased the voltage but increased the frequency, same current remains. Yeah, next question. The voltage marked Vx in the is given by, he is asking this Vx, this is Vx, this is the reference. Let's take this one as a reference, 0 volts. Let's write KCL there. Vx by 1 is the current in this one, is the leaving current. This current, see, this is 3 volts, right? But if I want to apply, this is 3 volt, okay, this is 3 volt. Yeah, this current is Vx minus 3 by 2 is this current. These two currents are leaving, but this current is entering, is equal to 6. How much it is? 1.5 Vx is equal to 7.5. So 3 by 2 Vx is equal to 15 by 2. So Vx is equal to 5 volts simply. Choice A. Simple question. See, question looks big, but which method you are applying, you will get by practice. You'll get by practice. Yeah. Let's see. These are all the total 20 questions for this week for your HPCL preparation, HPCL examination preparation for electrical and instrumentation engineers. Okay. Next week also YourPedia comes with some good 20 questions for this preparation of HPCL. Okay, join your hands with YourPedia. You all know that YourPedia is the market leader in this competitive examinations. Join your hands with YourPedia. Start preparing with YourPedia. Thank you.